All right, here we go. We are going to talk about section 4.5 today. We are going to prove congruency by angle, side, angle, and angle, angle, side. We've already learned about side, side, side now. We've learned about side, angle, side, and now we're adding two more postulates to our arsenal, if you will. So if you look here on this particular triangle, you have an angle that's congruent to an angle over here, and then you have a side, same side, a congruent angle over here, and a congruent angle here. So now you have angle, side, angle. Now, last section we talked about included, for those of you who watched the video, and again I encourage you to tell all your friends to watch the video, but for those of you who watched the video, you remember we had the included angle last time, which was the side, angle, side. So the included angle was the angle in between the two congruent sides. Now you have the included side, which is the angle in between, the side in between the two angles. So just make sure you understand that vocabulary about the included side and so forth. Okay. Now, I want to quickly kind of dispel some kind of a common misconception that students have. Just because these angles are congruent does not make these triangles congruent. There's no such thing as angle, angle, angle. Okay. What I mean by that is this: is that you could have a triangle that has a sides of 3, 4, and 5, and then you could have another triangle that has a sides of 6, 8, and 10, and they can all have the same angles, but obviously the one triangle is going to be bigger than the other. Angles are proportionate, okay? So you have to understand that. You can't, just because the sides are the same does not mean the angles are the same. Likewise, just because the angles are the same doesn't make the sides the same. So you have to be careful. Now, later on, you're going to find out if you have two sides that are the same, okay, it's possible that, well, we'll talk about that later. I don't want to get you confused. But just understand that just because three angles are the same measure doesn't mean the sides are the same. Remember, they all have to equal up to 180 degrees, right? So just because you have three common angle measures does not mean that the sides are the same. There's no such thing as the angle, angle, angle postulate, okay? All right, so let's take a look here. Here we have an angle congruent to an angle here, an angle congruent to an angle here, but then you have a side congruent to a side here, okay? So now you have angle, angle, side, right? So up here we talked about angle, side, angle. Here we're talking about angle, angle, side. It's basically telling you that that third angle theorem makes the angles congruent and the sides congruent, okay? So with our third angle theorem, we know that this angle right here, because these two are congruent, this angle right here is going to be congruent to this angle right here. That's our third angle theorem. And since this angle is going to be congruent to this angle right here, and we already have a side, it's going to make your other sides congruent, okay? With this other part of this thing, because this says the third angle theorem makes the angles congruent. Okay, that means all these angles are congruent, and the congruent side makes the sides congruent and not proportionate. What that's saying is because you have this congruent side, it's going to force all these other ones to be congruent as well instead of proportionate. Because remember, again, if I have three angle measures that are the same, I can have similar figures. If you remember from Algebra 1, or 8th grade math, you have with similar figures. We do scale factor. We dilate by enlarging and reducing figures. They still have the same angle measures. Even though the shapes have gotten bigger, the angle measures are the same when you dilate those triangles. So those become proportionate based on the scale factor. Well, whenever I have two angles that are the same and then a side that's not included, remember it's not the not included side, then I now force the sides all to be the same and not just proportionate based on the scale factor. I know that's probably a little confusing. If you have any questions, write that down. Come see me, and I can clarify it to you maybe face-to-face and kind of help you understand that a little bit better and draw some stuff on the board if you need me to. All right, so let's put this stuff to work. Okay, let's just go ahead and recap. If I'm dealing with three sides, what am I dealing with? What postulate? That's right, side, side, side. Okay, here I have a side and angle side. What is that one? Pretty simple, side, angle, side, or as I just talked to somebody in past today, they call it the SAS, or you can call that the Jasmine postulate. Just kidding, joke. Okay, here I have angle, angle, side, right? Okay, so I have an angle congruent here, and then the non-included side, so that's your angle side. Okay, what about this one? I have an angle, a right angle, and a side. No, I don't have angle side. Think about it. You'll get it in a minute. Okay, we don't use angle side, even though technically that is angle side, right? We don't really use it. It is because this is a right triangle, it is the hypotenuse leg. Okay, hypotenuse leg. And then here we have angle side angle. Okay, and that's our last one, angle side angle. So all of these are now arsenals in your toolbox in order to help you prove that triangles are congruent to one another. So let's go ahead and jump right into a proof, because we love proofs in geometry, do we not? I hear you. I can hear you from at my house right now, cheering inside, being so excited about proofs. I can feel it. You're just sending me some good vibes right now. All right, here you go. We want to prove that triangle ABF is congruent to triangle EDF. Okay. What's given is that angle CBF, okay, that's not even on the inside of those triangles, is congruent to angle CDF. That's where our markings are right here. Those two angles are congruent. And it's also congruent that BF is congruent to FD. Okay, so we have those things now. So now, in order to prove this to be congruent, I need to have either side, I need to have side, I need to have angle side, angle, or a hypotenuse leg, except we haven't proved this to be a right angle. All right, so where do we start? I probably want to get an angle, at least one angle here. You know, this angle right here, ABF. Okay, ABF. Not that. Or I also want to get maybe possibly BFA or DFE. Okay, so I want to look at this angle here because it's next to my congruent side, or maybe this angle here because it's next to my congruent side, or this angle here because it's next to my congruent side, or maybe angle D over here because it's next to my congruent side. I need to get one of those angles because that'll help me. So what can I do? Okay, you can go in a couple different orders here. All right, well, first of all, the reason they give us this right here is because now we know that angle CBF and angle ABF are supplementary. They equal 180 degrees. We also know that angle CDF and EDF are supplementary. They equal 180 degrees. How do we know that? Yeah, they're just a linear pair, right? So it's a linear pair postulate. Okay? Whoops. So if these are a linear pair, and essentially, let's say this is 30, this is going to have to be 150, right? Well, if this is 30, that means this is 30, which means this has to be 150. So now can you say that angle ABF is congruent to angle EDF? Yeah. And you can say it's congruent because they are the congruent supplements theorem, which basically says that if two angles are congruent to the, or supplementary to the same angle, then they are congruent. Okay, so two angles, these two angles are supplementary to the same angle, essentially this one or this one, that makes them congruent. So now I have angles B and D congruent, or ABF and EDF more appropriately. Okay, so I need either this side to be proven congruent with this side, so AB to be congruent with DE in order to get side angle side, or I need to prove that angle AFB right here is congruent to angle EFD right there. Hopefully this one stands out to you pretty clearly. Okay, so that's what we're going to go for. Angle BFA is congruent to angle EFD, and why is that? Pretty easy. I think everybody remembers this one. That's right, vertical angles congruency theorem, right? So now I have this angle, side, and this angle congruent to this angle, side, this angle. So now, again, make sure you pay attention to the order. I can show you that triangle ABF is congruent to triangle EDF, and that is because of angle, side, angle. Pretty easy. Again, hopefully as you continue to work with these, you start to get more comfortable with these theorems and these proofs. The more you really, honestly, there's no magical pill. Somebody asked me in class today, well, if I'm having a hard time with proofs, what can I do? And to be completely honest with you, it's just more practice. I know you don't like to hear that, but that's the truth. It's more practice. It's nothing more than that. You can come see me and I can come walk you through them, but it's simply more practice and really memorizing that vocabulary, okay? One of the things I also want to draw your attention to is you don't have to prove these angles, all the angles, to be congruent. Now I can just go straight from here to the triangles. Somebody today in class was also showing me that they proved the angles to be congruent, a third angle to be congruent. You don't need to. I don't care about BAF and DEF. Okay, I've already worked out these other two. And that's pretty much it. That pretty much closes out 4 or 5. Okay. Here's our homework right here. Let me get this out of your way. There's our classwork for tomorrow. If you watch the video and you're ready to go, or if you're absent, this is your homework. Otherwise, it'll be due on Monday. So I will see you guys tomorrow. Have a safe, fun evening. Try to be nice to those kids out there. And again, if you have any questions, write them down. I'll see you tomorrow morning.